Functions. Functions are one of the most important concepts in this entire book, so we start off with them here in the second chapter. Some people refer to functions as the atomic unit of a program, since programs are built out of functions. In fact, functions have many of the same properties and affordances as programs. Fundamentally, you can think of a function as a miniature program with its own input, processing, output workflow. In other words, they are reusable chunks of code. Functions are critically important not only to this chapter, but to this course, and even to the rest of your career as a computer scientist. The first two sections of this chapter are dedicated to calling functions, which is how functions are used. When you call a function, you put parentheses after the name of the function. Sometimes you also provide arguments, which are values that go inside the parentheses. You might think of a function as a mysterious box that you cannot see inside of. The arguments are slots on top of the box that you can put data into. Then, more data will come out of the bottom of the box, which we call the returned values. These values are substituted back into the program, just like how other operations evaluate to other values. Python has many built-in functions, some of which you are already familiar with. Input, int, round, and print are 4 examples shown here. The subsequent 2 sections are about how to define your own functions. Critically, the programmer must use the def keyword and provide a lot of information about the function. One of the most important pieces of information is the name of the function, which in the example shown is average. The programmer must also provide formal names for the expected arguments to the function, and the expected types of those names. These names are called parameters, and they become variables for the function to use. The programmer must also include the expected return type for when the function is called, which in this case is the greater than int part. The line with the def keyword is known as the header of the function, and the following indented lines below it are the body. The first line of the body is string literal value, known as a docstring, that explains the function's purpose. Subsequent lines of the body are the instructions that will be executed when the function is called, with the final line being the return statement. Once defined, functions can be called just like the built-in functions. Just because you wrote a function, does not mean the function works correctly. An entire section is dedicated to talking about how functions must be unit tested to try to prove their correctness. A unit test is a special line provided in the program that shows an example input and the expected output when the function is working correctly. Unit testing requires strong critical thinking skills. In this course, we use a library named Bakery that has a special function named assert_equal that can be used to test your programs. Going forward, we will expect you to test all of your functions. At the end of Part A, there is a quick chapter about different debugging strategies. Since programs get significantly more complicated around now, it is useful to learn how professional programmers go about figuring out how to make their programs work correctly. Strategies covered include learning how to talk to rubber ducks, fencing in wolves, and making random guesses. The indented region under the header of a function is known as the body of the function. The body of the function is the same concept as the body of a module. In other words, every program has at least one body, and then every function also has its own body. A separate but related concept is the idea of scope, which is a body that controls the lifetime of variables. Any variable inside of a scope will only be available inside of that scope, so when that scope ends, the variable is no longer available. There is also a special global scope for the entire program, but you must be especially careful to avoid global variables inside of your functions. We previously mentioned that the first line of the function's body should always be a string literal. Specifically, it should always be a triple-quoted string with specially formatted contents. This is a special kind of comment that Python recognizes as the function's docstring. A docstring is a very important kind of documentation that helps explain the purpose of a function for other programmers. Each line of the string should be indented to match the body of the function. A common mistake is to try to put the docstring before or after the function. However, docstrings only count if they are the first line of the body of the function. The third section of Part B is one of the most critical and confusing ideas, which is data flow. Metaphorically, data flows through a program from its inputs to its outputs, being transformed and modified along the way. Up until now, that flow went from the top of the module to the bottom. But now, program execution will actually jump around according to the rules of function calls and returns. It is critical to track what data is available at each step of the program. This is especially true when we start calling functions from within functions. The final section of this chapter acknowledges that although Python has a lot of useful built-in functions, we will often need even more functions. Just like how variables can be defined in other modules, functions can also be defined externally in modules and then imported. Once imported, they can be used to build truly magical programs. Some of the examples in this section involve creating graphics using a library named Designer.